What if I told you that the smartphone in your hand, the cordless vacuum you just used, or even the life-saving MRI machine all exist because humans decided to go to the moon? Going to the moon was hard, really hard. The goal was to win the space race and prove that the United States could go farther than anyone had before. But what most people didn't expect was that the Apollo missions would change far more than space exploration. The technology built to reach the moon ended up transforming life here on Earth. From smartphones and handheld tools to the life-saving machines, so much of what we take for granted today began with Apollo. Let's take a look at some of the innovations the Apollo missions gave us, and how they continue to power our lives today. Integrated chip systems. Apollo marked the moment the world stopped boasting about how big their computers were and started talking about how small they were. When NASA set out for the moon, computers were massive, room-sized machines packed with vacuum tubes, and that was a big problem. The solution came in the form of integrated circuits, tiny silicon chips capable of performing complex calculations, which powered the Apollo guidance computer. While NASA didn't itself invent or build the ICs, its Apollo program was their largest single consumer between 1961 and 1965. And their massive demand for these chips during the program accelerated their production, improving quality while drastically lowering costs. The same miniaturized technology that guided Apollo spacecraft safely to the moon laid the foundation for the microprocessor revolution. Soon after, integrated circuits became the heart of personal computers, smartphones, cars, and every digital device we use today. The fly-by-wire system. Apollo Guidance Computer was the first fully digital, software-driven computer that humans staked their lives on. And its success led to NASA's subsequent development in the early 1970s of fly-by-wire technology now fitted to almost every modern aircraft. Instead of employing mechanical links that included cranks, pulleys, and hydraulics, today flight controls are electronic and coordinated by computer systems which are lighter and safer than the mechanical ones. Astronauts entered commands on a small keypad called the diski, and the onboard computer translated those digital signals into precise control over the spacecraft's thrusters. This technology allowed for smooth, computer-assisted flight, helping astronauts land the lunar module safely on the moon. After the moon missions, NASA adapted the same concept for aircraft, testing it on an F-8 Crusader jet in the early 1970s. The results were revolutionary. Planes could now be controlled electronically, making them lighter, safer, and more responsive than ever before. Today, every modern jet uses fly-by-wire systems, a direct descendant of Apollo's innovation. Dustbuster and cordless power tools. One of the most practical innovations from the Apollo program is something you might have sitting in your garage right now: cordless power tools. During the program, NASA needed a way for astronauts to collect lunar rock samples and drill into the moon's surface. But there was one obvious challenge. There were no power outlets on the moon. To solve this, NASA partnered with Black & Decker to create lightweight, battery-powered drills capable of working in low gravity and extreme temperatures. That same research later led to one of the most iconic household tools ever made, the Black & Decker Dustbuster. Originally designed using the same motor technology created for Apollo's lunar drill, the Dustbuster became a commercial hit and transformed how people cleaned their homes. Over the decades, these innovations evolved into the rechargeable lithium-ion systems that power nearly every cordless device we use today. Space blankets. Moon's surface is brutal, scorching heat in sunlight, freezing cold in shadow, due to lack of an atmosphere. To protect Apollo spacecrafts and astronauts from those extremes, NASA developed a new material called multi-layer insulation, thin plastic films coated with aluminum that reflect 97% of radiant heat. That same material became famous as the space blanket, the lightweight metallic sheet used by emergency responders, hikers, and marathon runners to retain body heat. Originally designed to regulate spacecraft temperature, it became an inexpensive, life-saving product on Earth. The MLI is now used in emergency kits given to athletes to prevent hypothermia, and even in architecture to keep buildings energy efficient. So simple, yet so effective. Food safety and HACCP. One of NASA's biggest fears during Apollo missions was maintaining an absolutely strict food hygiene and ensuring that all food was free of microbes that could make astronauts sick. Even a mild illness could jeopardize an entire mission. To prevent it, NASA partnered with the Pillsbury Company to design a system that ensured zero contamination. They called it HACCP, Hazard Analysis and Critical Control Points. Instead of testing food after production, HACCP analyzed every step, identifying potential risks and implementing strict controls. It was the first proactive food safety system ever created. Today, HACCP is used worldwide in restaurants, factories, and hospitals, forming the backbone of modern food safety laws. MRI and CAT scans. In the 1960s, NASA had to build computers to process massive amounts of real-time data, tracking spacecraft position, thruster engines, and astronaut health with incredible precision. These systems used digital signal processing, a revolutionary technology at the time, allowing engineers to convert raw data into meaningful visual information. After the Apollo era, the same core principles became the foundation for medical imaging technologies like CAT scans and MRI machines. Both rely on rapid signal detection and reconstruction algorithms that trace directly back to software models first refined by NASA scientists. This meant doctors could, for the first time, look inside the human body non-invasively, detecting diseases, tumors, and injuries with clarity that once seemed impossible. And just like Apollo's guidance computers guided astronauts to the moon, these medical systems now guide doctors through the human body with pinpoint accuracy. Helium-3 deposits. When Apollo astronauts brought lunar soil back to Earth, scientists found traces of helium-3, a rare isotope implanted by billions of years of solar wind. Unlike nuclear fuel on Earth, helium-3 is non-radioactive, and when used in fusion reactors, it could produce vast amounts of clean, safe energy. Though the technology is still developing, just a few tons of helium-3 could theoretically power entire nations, with no greenhouse gases and no nuclear waste. Future lunar missions aim to explore these deposits, making the moon not only a destination, but a potential energy source for humanity's future. Stay curious, share this video, and subscribe for more.